Welcome! In this video, we'll explore the basics of Object-Oriented Programming, or OOP. This session will focus on the theoretical concepts of OOP, so if you're looking for coding examples, stay tuned for our next video. Whether you're new to coding or just curious about how software is organized, this introduction will give you a solid foundation. By the end of this video, you'll understand 4 core concepts: encapsulation, inheritance, polymorphism, and abstraction. Let's dive in. Object-oriented programming is a way of designing software around objects. Think of objects like real-world entities. They have data, called attributes, and actions they can perform, called methods. Popular languages like Java, Python, and C++ use OOP to help developers write clean, reusable code. Encapsulation is the concept of restricting direct access to some details of an object while exposing only what is necessary. A simple real-world example is a bank ATM. When you insert your card and enter your PIN, you can access your account. However, you don't see the complex process of verifying your identity and handling transactions. This is hidden from you. The ATM provides a simple interface, and that's what you interact with. Similarly, in programming, encapsulation hides the internal workings of an object and only exposes necessary functionality, improving security and organization. Inheritance is a mechanism that allows a class to inherit properties and behaviors from another class. This promotes code reuse and reduces redundancy. Imagine a family tree where children inherit traits from their parents, such as eye color or height. Similarly, in software, if we create a general class like vehicle, we can then create specific types like car and bike that automatically inherit common attributes like wheels and an engine. This makes development more efficient and maintains consistency across related objects. Polymorphism means many forms. It allows different classes to respond to the same action in different ways. A real-world example is a universal remote control. The same power button can turn on a TV, a music system, or an air conditioner, but each device responds in its own unique way. Similarly, in OOP, different objects can use the same method name, but implement their behavior differently. This makes systems more flexible and adaptable to different scenarios. Abstraction helps us focus on essential features while hiding unnecessary details. Think of driving a car. You use the steering wheel, accelerator, and brakes, but you don't need to understand how the engine, fuel injection, or transmission work. You interact with a simple interface, and the complex inner workings are hidden from you. In programming, abstraction works the same way. It simplifies interactions by exposing only what's necessary and hiding the rest, making systems easier to use and maintain. Now that we've covered encapsulation, inheritance, polymorphism, and abstraction, let's summarize how they work together in OOP. These principles help us build well-structured, reusable, and efficient code. Just like in real life, where we organize things into meaningful categories and avoid unnecessary complexity, OOP helps us structure software in a logical and scalable way. To summarize, encapsulation protects data and controls access. Inheritance allows code reuse and hierarchy. Polymorphism makes systems flexible by enabling different behaviors with the same method name. Abstraction simplifies interaction by hiding unnecessary complexity. These 4 principles form the foundation of object-oriented programming. Understanding them will help you design efficient and scalable software. Continue exploring OOP concepts and try applying them in different projects. If you found this video helpful, hit like, subscribe, and check out the description for additional resources. Leave a comment with any questions or topics you'd like covered next.